Artificial intelligence, some of the most used and least understood words in our industry. I'm sure that many of you today will agree with that. So what is artificial intelligence? Artificial intelligence is the use of smart machines, or computers as we call them, to replicate tasks that previously required human intelligence. So what is human intelligence? This is the general mental ability for reasoning, problem solving, and learning. I am here today to show you some examples of how we use computers to replicate human intelligence. On the screen, you can see the data science maturity evolution curve. We're in a world now where we've moved from the left-hand side, business intelligence, to the right-hand side, artificial intelligence. No longer are we asking what happened from data, but we're using the same data to predict what will happen. With recent advantage in data science and technology, we're going even further in the AI world now, and we're asking from the data, what should we do, and even how do we continually improve? But what's interesting is the majority of our clients do not realize that the data and information that they require for this already exists within their existing building, either from a building management system or a chiller plant manager, as we've heard. Or if the data doesn't exist, we can get it from low-cost devices such as IoT sensors, which we've heard a lot about today. I want to start about talking about humans versus machines. It's a common misconception that humans and machines will compete against each other and even fight against each other. In fact, they will not be competing, but they'll be working together. This is called augmented decision-making and is the future of work and business and is already here today. So, what did we do as competitive humans at Engie? We tested ourselves against the AI, of course, to see what would happen. The data on the screen is from a commercial project in Abu Dhabi, where we wanted to compare our traditional engineering processes with an energy engineer against an AI model to see who could detect a variance in energy consumption first. Our results showed us that the machine learning model detected a variance in energy consumption 60 days before our traditional processes with an energy engineer. Imagine how much wastage in energy that would be in a significantly energy-consuming asset, particularly in the summer months of your buildings. The simplest form of intelligence is descriptive, when we talk about looking at data, what has happened, still on the BI half on the left-hand side. But instead of checking things manually, we used rule-based algorithms to detect variance to bring a lot more productivity to our processes. There's two approaches to this. The first is from an engineering point of view. We sit with our engineers, we understand what they do, how we do it, and we try and program their intelligence. The second way to look at this is from a data science point of view. With no engineering input at all, what can we detect from variance and anomalies within the data set? But what we've found is the solution often sits somewhere in the middle of these two, is our sweet spot. On the screen, you can see an algorithm that we created to detect variance in energy data, a process that would typically take 1 or 2 days for an engineer on site, takes a couple of seconds to run as an algorithm. So there's massive productivity gains from this type of project. As I said, this is just a simple BI example in terms of detecting from previous data, but I'll go on to some AI examples where we not only predict but respond to anomalies. The first stage in our AI journey, the first step of the 3 that we saw on the curve before, is predictive intelligence. How do we predict what will happen? The data on the screen is from a commercial project in Dubai, where we were able to forecast the energy performance of chiller plant with 98% accuracy. This allowed us to complete predictive analytics, which allowed us to optimize the controls on site, and we achieved a 15% reduction in energy savings. Not only that, the same live data is used to continually monitor the site to ensure the assets are operated and maintained in the most efficient way. And on top of that, we used it for verification of the energy savings and assuring they were sustainable over time. Second step in our journey is the prescriptive intelligence. looking at the data and using a model to tell us what should we do about it. The example on the screen is from a commercial project in Abu Dhabi, where we combined asset, energy, and operations data into a model and use it to advise us when to intervene with the asset. Instead of looking at the asset periodically, the model would tell us when was the best point to intervene from an energy point of view and even an O&M point of view. Furthermore, the model was able to advise on the root cause analysis of some of these issues, either from what it had learned historically in terms of the fault or from the specific variance that it saw in the performance data. Just to give you an example from this data set, the model was able to identify fan, sensor, and variable frequency drive issues that were not seen before from the operations team on site. And the final step today in our AI journey, although I'm sure that will change very soon in the future, is cognitive intelligence, all about how do we continually improve what we do automatically. This is a commercial project in Dubai where we combined HVAC, weather, and occupancy data with forecasts to make recommendations of how we should optimize the building. But not only were the recommendations made, those recommendations were autonomously sent back to the building management system and the controls updated automatically. That was continually improved on an hourly, daily, weekly basis. This is called a cognitive optimization system, and we're able to achieve an additional 19% energy saving on top of an already well-controlled site. And the thing to remember about this example is this was without any human intervention at all. At Engie, we call this our Smart O&M solution. We combine energy, equipment, and space data to create models and algorithms to monitor assets and improve their performance automatically across cities, communities, industries, and properties. Our services drive environmental and energy efficiency for our clients, improve the service quality, and lead to cost savings for them.